Q4160. If you fly into severe turbulence, which flight condition should you attempt to maintain? A. Constant airspeed, VA. B. Level flight attitude. C. Constant altitude and constant airspeed. The correct answer is B. When flying in severe turbulence, maintaining positive aircraft control may be nearly impossible to do. In attempting to maintain a constant altitude, the stresses applied to the aircraft are greatly increased. Stresses will be lessened if the aircraft is held in a constant attitude and allowed to ride the waves. Wide fluctuations in airspeed will probably have to be tolerated in order to reduce aircraft stresses. 4916. If severe turbulence is encountered during your IF or flight, the airplane should be slowed to the design maneuvering speed because the A. Maneuverability of the airplane will be increased. B. Amount of excess load that can be imposed on the wing will be decreased. C. Airplane will stall at a lower angle of attack, giving an increased margin of safety. The correct answer is B. If severe turbulence is encountered during an IF or flight, it is recommended to slow the airplane to the design maneuvering speed. This is because slowing down to the design maneuvering speed has several benefits in terms of aircraft safety and structural integrity. The amount of excess load that can be imposed on the wing will be decreased. By reducing the speed to the design maneuvering speed, the excess load that can be imposed on the wing is decreased. This is important because severe turbulence can subject the aircraft to sudden and extreme changes in airspeed and vertical acceleration. Slowing down to the maneuvering speed helps to ensure that the wings and other structural components of the aircraft are not subjected to excessive stress or loads beyond their design limits. Slowing down to the maneuvering speed also provides an increased margin of safety against stalling. It allows the aircraft to operate at a lower angle of attack, reducing the risk of reaching the critical angle of attack where the wing may stall. This increased margin of safety helps to maintain control of the aircraft in turbulent conditions. 4210. A pilot reporting turbulence that momentarily causes slight, erratic changes in altitude and/or attitude should report it as A. Light turbulence. B. Moderate turbulence. C. Light chop. The correct answer is A. Light turbulence refers to turbulence that causes slight, rapid, and rhythmic bumpiness without any significant changes in altitude or attitude. It may require some attention to maintain a desired altitude or heading, but the aircraft remains in positive control at all times. Moderate turbulence, on the other hand, refers to turbulence that causes changes in altitude and/or attitude, but the aircraft remains in positive control. It requires the pilot to exert some effort to maintain control and may cause variations in airspeed or vertical speed. Light chop is a term used to describe turbulence that is characterized by relatively small, rapid changes in altitude and/or attitude, similar to light turbulence. It is typically associated with atmospheric disturbances such as wind shear or localized convective activity. In the given scenario, where the turbulence only momentarily causes slight, erratic changes in altitude and/or attitude, the appropriate report would be light turbulence. This helps to provide accurate and useful information to other pilots and air traffic controllers about the encountered turbulence. 4148. What are the requirements for the formation of a thunderstorm? A. A cumulus cloud with sufficient moisture. B. A cold front pushing into an area of moist, stable air. C. Sufficient moisture, an unstable lapse rate, and a lifting action. The correct answer is C. Thunderstorms are formed through a specific set of atmospheric conditions. These conditions typically include sufficient moisture. Thunderstorms require an ample amount of moisture in the lower atmosphere. This moisture provides the necessary fuel for the storm's development. Unstable lapse rate. A lapse rate refers to the change in temperature with altitude. For thunderstorms to form, there needs to be an unstable lapse rate, meaning the temperature decreases rapidly with height. This allows warm and moist air near the surface to rise rapidly, leading to vertical instability. Lifting action. Thunderstorms require a lifting mechanism to initiate the upward motion of warm and moist air. Several factors can cause the lifting, including orographic lifting. Air is forced to rise as it encounters a mountain or elevated terrain. Frontal lifting. When a cold front advances into an area of warm, moist air, it acts as a lift and helps trigger the formation of thunderstorms. Convergence. When air flows from different directions converge and collide, they are forced to rise, promoting storm development. Localized heating. Intense surface heating, such as from the sun heating the ground, can create thermals that initiate upward motion. 4126. Which weather phenomenon signals the beginning of the mature stage of a thunderstorm? A. The start of rain at the surface. B. Growth rate of cloud is maximum. C. Strong turbulence in the cloud. The correct answer is A. The mature stage of a thunderstorm is characterized by the most intense and active phase of the storm. During this stage, several key features become prominent. However, the most significant indicator of the mature stage is the start of rain at the surface. In the initial stages of a thunderstorm, updrafts carry moist air upward, causing the formation of towering cumulonimbus clouds. These updrafts feed the storm and promote the development of the cloud. As the storm progresses into the mature stage, the updrafts continue to sustain the storm's strength. At this point, the cloud becomes tall and dense, with the upper portion often spreading out in an anvil shape.